Hey everyone, we're here with lesson 3.2 about expanding polynomials. And here we're going to talk about multiplying polynomials with each other. So when we multiply polynomials, we want to make sure that we multiply each term in one bracket by each term in the other. Now there is an acronym that we use when we're multiplying binomials together. And that acronym is called FOIL, and maybe you've heard of that before. But FOIL stands for first, outer, inner, and last. And that just gives us a map of how we want to multiply each of the terms together. After multiplying terms, we want to make sure that we simplify by collecting like or similar, whatever term you like to use, similar terms. So let's go straight to an example. We want to expand and simplify. Expand means that we're going to multiply. And we're first taking a look at a binomial with a binomial. We have x plus 4 times x plus 2. So if we were to map out our acronym of first, outer, inner, last, I'm going to try and connect them. So we have the first term of the first bracket multiplied with the first term of the second bracket. Then we have the outer, so the outer term of the first bracket with the outer term of the second bracket. Then we have the inner term of the first bracket times the inner term of the second bracket. And then we have the last term of the first bracket times the last term of the second bracket. So let's work with that and we'll go from there. So x times x is going to give me x squared. X times 2 is going to give me 2x. 4 times x is 4x. And then 4 times 2 is positive 8. Now we take a look. We have similar terms in the middle here, so we can collect those and we'll be done. X squared, 2x plus 4x gives me 6x plus 8. And there are no more similar terms to collect. So we're all done. Let's take a look at B. And again, I'll just map out that first, outer, inner, last. So first term with first term, outer term with outer term, inner term with inner term, and then the last term with last term. So 2a times 2a is going to give me 4a squared. 2a times 1 is going to give me positive 2a. Then we have negative 1 times 2a is going to give me negative 2a. And then negative 1 times 1 is going to give me negative 1. Our middle terms are similar. And if we take a look at them, they actually cancel each other out. So what I'm left with here is 4a squared minus 1. So here we have 5m minus 6, but we want to square it. So let's go ahead and rewrite this. What would this look like? I'm going to squared, remember, is one thing times itself twice. So this is really 5m minus 6 times 5m minus 6. Then we can do our first, outer, inner, last. First, outer, inner, last. And 5m times 5m is 25m squared. And 5m times negative 6 is negative 30m. Negative 6 times 5m is negative 30m. And negative 6 times negative 6 is positive 36. Our middle terms are similar, but they're not opposite here. So we have 25m squared minus 60m plus 36. Same thing happens with D, 4y plus 7 squared. We rewrite it as 4y plus 7 times 4y plus 7. We'll go ahead and do our FOIL. First, outer, inner, last. So 4y times 4y is 16y squared. 4y times 7, that's 20, positive 28y. 7 times 4y is positive 28y. And 7 times 7 is 49. We simplify those middle terms. 16y squared plus 56y plus 49. And we're done with that one. Now let's take a look at something that we have here. We have 3 out in front, so 3 times 2x plus 5 times 9x plus 1. One of the things I like to do here is just clear out that first coefficient. So we use the distributive property here, and I'll distribute the 3 into the first bracket. Now this is all multiplication, so we can't multiply 3 by the first bracket and then 3 by the second bracket, because essentially then we'd be multiplying by 9. So let's clear out the first bracket using distributive property, and we'll have 6x plus 15. And then we didn't address the second bracket 9x plus 1 yet, but we will now. So now we can use our FOIL, and we'll do first, an outer, an inner, and last. So let's try and keep track here. We're going to end up with some pretty big numbers. So 6x times 9x is going to give me 54x squared. Then I have 6x times 1, that's going to give me positive 6x. Then I have 15 times 9x, it's 135. And of course, I'm getting some of these from my calculator. And then 15 times 1, that's positive 15. And we have the x terms in the middle that we can collect. And we'll end up with 54x squared. 6x plus 135x is going to give me 141x. And then plus 15. We'll take a look at f. This one's a really long one because we have a binomial times a binomial squared. So let's take a look at what we have. We might want to deal with the squared one first. With multiplication, it actually doesn't really matter. So let's do that. Let's see. Let's keep 3n minus 1. And then we'll have times 2n plus 3 times 2n plus 3. So we have to write it out this way before we decide which multiplication we want to do. It's not like exponents where you can just distribute that exponent of 2 into the 2 and the 3 inside the bracket. So let's go ahead and get rid of that. So let's go ahead and do the 2 last brackets. So first an outer, inner, and last. We haven't touched the first bracket yet, 3n minus 1. And I'm going to keep this in brackets till we're all done with it. We have 4n squared plus 6n plus 6n plus 9. I'm going to go ahead and collect those like terms. 3n minus 1 times 4n squared plus 12n plus 9. All right, so now we have a binomial times a trinomial. And FOIL doesn't actually work, but the idea of taking every term in one bracket and multiplying it by every term in the other bracket, that is still what we have to stick with. So what's that going to look like? First, we're going to take the 3n. We're going to multiply it by every term in the second bracket. After that, we'll take the next term, which is negative 1, and we'll multiply that by every term in the second bracket. Okay, stick with me here. We have 3n times 4n squared. And that will give me 12n cubed, because an n times n squared, we have to multiply those exponents, so we get n cubed, plus 3n times 12n gives me 36n squared. And then we have 3n times 9, which is going to give me 27n. Next, I'm going to take a look at the green. So I'll have negative 1 times 4n squared, and that'll be negative 4n squared. Negative 1 times 12n, that'll give me negative 12n. And negative 1 times 9 is going to give me negative 9. So in this big, long expression, there's got to be some things that can be collected. And in fact, we have an n squared term there and there. And then we have an n term here and here. So those are the only things that can be collected. So let's simplify. 12n cubed, 36n squared minus 4n squared is going to give me 32n squared. 27n minus 12n is going to give me 15n. And then minus 9 at the end. So there's the full expansion between that binomial and the binomial squared. So there are some special cases when it comes to expanding polynomials, and it might be, if you can recognize them, might be helpful in terms of not having to draw those arrows that I've been drawing and using FOIL and multiplying binomials and trinomials, but only two situations. If we have a squared binomial like this, and we remember the pattern, we can just take the square of the a term plus the square of the b term, and we fill in the middle with 2 times whatever a is and whatever b is. So if we go back to the examples that we just did, the example that we can see here was the 4y plus 7 squared. So we might have recognized it as similar to a plus b squared. We have 4x plus 7 squared. So that example was D. That's where we saw that. And then we had another one where it's a minus b squared. And in this case, you could just map out the answer by taking a squared, adding b squared, and then subtracting the 2ab in the middle. This example from the front page is the 5m minus 6 squared. And that example was C. And then we had an example where we had two binomials, but they had opposite signs. So the sign here and the sign here were opposite each other. So if we see that pattern, we know we can automatically go to a squared minus b squared. And this example was B, where that middle term, when we were done, ended up canceling out. So 2a minus 1 times 2a plus 1, right? Those middle signs are opposite each other. So let's see if we can use some of these shortcuts. So the first one we come to is 5x minus 2 times 5x plus 2, and they're almost the same except for these signs in the middle are different. So if we recognize the pattern, we can just go straight to 5x times 5x would be 25x squared, and negative 2 times 2 is going to give me negative 4. And we're done, and we don't use FOIL. Okay, but it's only based on the fact that you can memorize the special cases. So 3m plus 4 times 3m minus 4, again, they're pretty much the same except for the middle signs, and they're opposite. So I recognize that as a special case. 3m times 3m is 9, m squared, and 4 times negative 4 is negative 16. All right, now we take a look at 5a plus 4 squared. Remember, there's a pattern here where we would square the first term, square the second term, and then we have to make up the term in the middle. So I'm going to write that out for you. We have 25a squared. We don't know what we're going to put in the middle, but 4 times 4, that's going to be 16. Now, what has to happen in the middle is it has to be 2 times a and b. That's what has to fit in the middle. So a is 5a and b is 4. So knowing that pattern, we would have 25a squared plus 2 times 5a times 4 plus 16. If we simplify that middle, we have 25a squared plus 40a plus 16. And then we'll do this last negative example. So again, we see that this is a negative one, so 2 minus 7b squared. We recognize it as one of our special cases. So 2 squared is going to give me 4. 7b squared is going to give me 49b squared. And in the middle, it has to be 2 times a times b. So I'll have 4 minus 28b plus 49b squared. So again, if you can recognize some of the special cases, it shortens up the process a little bit. But don't worry, because the FOIL and the expansion always works the same. So I want to take a look at a couple of application problems. So finding the expression of the area for the following shape. So here we have a square, and the sides of the square are 4x plus 1 and 4x plus 1. Remember, area of a square is side squared. So area here is going to be equal to 4x plus 1 squared. And because this is a square, we end up with one of those special cases. So the expression for the area here is going to be 16x squared. In that middle, with that special case, we have to have 2 times 4x times 1, and then we have to have 1 at the end. So simplifying, I'll have 16x squared plus 8x plus 1. And that's the expression that represents the area of this square. So let's take a look at an example for a rectangle. Sides are not the same. These are opposite. So remember, the area then of a rectangle is the length times the width. And the length here is 2x plus 5. And the width is 2x minus 5. And if we remember our special cases, this is another one where the binomials are almost the same, except for the signs are opposite. So this will come out to 4x squared minus 25. Good. The last example here is an expression for volume. The volume of a cube is equal to length times width times height or depth. We'll call it h for height. And we have all the expressions. We have to multiply them all together. So let me zoom in a little bit here. This is going to be equal to 2x plus 3 times x plus 2 times 3x minus 4. So I'll go ahead. I'm just going to zoom in on the numerical aspect of this, and I'm going to do the 2 brackets at the beginning first. So here, there's no special cases, and I might want to map out, all of the multiplication that's going to happen So first and outer and inner and last, and that's just for the first two brackets. So 2x times x is 2x squared. 2x times 2 is plus 4x. 3 times x is going to give me plus 3x. 3 times 2 is going to give me 6. So that is the expansion of the first two. Going to keep this last bracket here. We haven't touched it yet. Let's simplify 2x squared plus 7x plus 6. And now we have to expand this, where everything in the first bracket has to be multiplied by everything in the second bracket. So let's see. 2x times 3x is going to give me 6x cubed. 2x times negative 4 is going to give me negative 8x squared. Sorry, that's a squared in there. Next, I'll deal with 7x times 3x. That's going to give me 21x squared. And then 7x times negative 4 is going to give me negative 28x. Then we have 6 times 3x. Let me change the color again. 6 times 3x. And that's going to give me 18x. And then 6 times negative 4. And that's negative 24. So we have like terms to collect. There's two x squared terms there, and there's two x terms there. And if we simplify and collect like terms, the expression for the volume, I think, comes out to 6x squared plus 13x squared minus 10x minus 24. Oh, and that's a long one. All right, I just want to show you one more thing because some of us are visual learners, and we have an alternate strategy that we call the box method. So let's see how that works. If I expand a plus b and a plus b, I can split the first binomial and put that terms in the top, and then do the same along the side. And then I go down the first column and the first row. I'll get a times a is a squared, a times b is ab, b times a is ab, and then b times b is b squared. So let's take a look at a numerical example. So if I have n minus 3 times n minus 3, I'm going to split one binomial, n and negative 3, and the other binomial along the side, n and negative 3. So n times n is going to give me n squared. That's where they match up. Then negative 3 times n is going to give me negative 3n. Then in the next row, n times negative 3 is negative 3n. And negative 3 times negative 3 is 9. So what we do here is we just collect our like terms. So n squared, but our like terms are right here. We have a negative 3n and a negative 3n, and I collect them right off the bat. So that is negative 6n, and then we have a positive 9. This is a similar example where I split up the binomial, 2n and 3, and 2n and 3, and I'll have 4n squared, 6n, 6n, and 9. I recognize that these are my similar terms, and I'm ready to just pull it out of the box. 4n squared plus 12n plus 9. And once again, n and negative 6. You can put 2n here, and -1 here. 2n times n is 2n squared. 2n times -6 is -12n. -1 times n is -n, and then -1 times -6 gives me +6. We can identify our similar terms here and here. And so I can just pull out the terms from the box. 2n squared, -n and -12n is -13n plus 6. And of course, I just want to do one long one with you. We can expand this to something bigger than a binomial and use it with a trinomial. So let's take a look. N squared. We're going to split that binomial into n squared and 3. And the trinomial is going to be split along the side. So we're going to put n squared, -3n, and -2. And then let's go ahead and cross multiply them. So n squared plus n squared is n to the 4. 3 times n squared is 3n squared. -3n times n squared is -3n cubed. -3n times 3 is -9n. -2 times n squared is -2n squared. And -2 times 3 is -6. So take a look in here. We seem to have like terms there and there. And that's it. So let's pull it all out. We have n to the power of 4 minus 3n cubed. We have -n squared plus 3n squared. So that is just +1n squared minus 9n minus 6. So I'm not sure if you're more comfortable with the box method because you're more visual, or if you want to just do the multiplying term of the first bracket by the terms of the second bracket. Again, I'm still visual, so I still use all those lines. But anyway, that is up to you. Decide what suits you better, and just give it a try on your worksheet. All right, everyone. See you soon.